In this lesson, we will discuss kinds of matrices, negative of matrices, and transpose of matrices. Before going to start questions, first of all, I will explain to you the kinds of matrices. Then it will be very easy to solve the questions. So there are different kinds of matrices. We will start from the row matrix. See, the row matrix is a matrix which has only one row. See, I will show you here with the help of example. Suppose I am writing 1, 2, 3, but you can write down any number 0, 1, 2, 3, 4, whatever, right? But it should be in one row. Then you have to enclose this row in a parenthesis, this in the large bracket. This is called a matrix, right? So in matrix, see here, horizontally it is called the row. So this is one row. So the matrix which has only one row is called the row matrix. I will here give you one more example. You can write down any. See, 0 real number. I will write down 9, 8 or 9. Then enclosed in this large parenthesis horizontally, we have to say it is row, right? So this is one row. Now we will move to the column matrix, right? So column matrix is a matrix which has only one column. Here I will write down, suppose 0, 7, 6. These are, in this way it is called column. Vertically we say column, horizontally we say it is a row. So this is vertically, and then you have to enclose it in this large bracket. It is called one column. This matrix has one column, so this is the column matrix, right? You can write down only 7, suppose, and 9, two elements, but it should be one column. So see, one column. If someone asks you how many rows, so horizontally it is rows, but vertically it is called column. So the matrix which has only one column is called the column matrix. Now is the null. See, the name indicates null matrix. All entries of the matrix should be 0. Suppose 0, 0, 0, 0. This is called the null matrix. If it has, suppose, one column but both are 0, so this is the null matrix. If it is like this, one row but all entries are 0, it is called the null matrix. Then is the identity and unit matrix. This is important, right? Diagonal entries are not 0 while non-diagonal entries are 0. Diagonal matrix. Sorry, we are here identity matrix. Then we will move on to the next slide. Diagonal elements are 1. Now see, I will show you here with the help of example. Suppose we have here 1, 0, and then 0 and 1. I will give you the concept of diagonal as well. In matrices, this is the diagonal. You have to follow from this corner to this corner, right? Not from here to here. This, from this to this. This is called the diagonal. So diagonal entries should be 1. Remaining all entries should be 0 is called the identity matrix or unit matrix. I will give you here one more example. Suppose 1, 0, 1, 0, 1, 0, and then, sorry, this is also 0, 0, 0, 1, and then you have to enclose in the large bracket. This is called the matrix. See, diagonal from this corner to this corner in matrices, right? Do not consider from here to here, from this, from left to right, and diagonal entries are 1. Remaining all entries are 0 It is called the identity matrix or unit matrix. So in this slide you have learned row matrix. If it has one row, is called the row matrix. If a matrix has a one column matrix, all entries are zero in a matrix, is called the null matrix, and diagonal entries should be one, remaining all are zero, is called the identity matrix, right? Move on to the square matrix. See, the number of rows should be equal to number of columns. Now, what does it mean? Here, I will give you the example. Suppose 2, 3, and here we will write down this 6, 4, 0, 2, 3. Right? In the last lesson, I told you the order of the matrix, or you can say the dimension of the matrix. So if someone asks you, okay, what is the order of this matrix or dimension? So I told you that always you have to write down rows first. This is one row, this is second row, this is third row. Horizontally, these are called rows. So we have 3 rows. How many columns we have? One column, two column, and this is the third column. So we have 3 column, 3 rows, and we have to write down dimensions 3 by 3. It is called 3 by 3. First represent the rows, second represents the columns. So if number of rows are equal to number of columns, it is called the square matrix. One more example, suppose 0, 2, 4 and 6, and then you have to enclosed in the bracket. See how many rows you have? 2 rows. And how many columns you have? 2 columns. So that dimension of this or order of this matrix is 2 by 2. Number of rows is equal to number of columns. This is called the square matrix. Now is the rectangular matrix. Number of rows and number of columns are not equal. See, suppose if I will write down 1, 2, 3, 4, 7, 6 and 8. Suppose this is one matrix. How many rows? Always you have to write down rows first. So 2 rows. And how many columns? 1, 2, 3. So see, number of rows and number of columns are not equal. So this is called the rectangular matrix. Clear? If the number of rows are not equal to number of rows, then it is rectangular matrix. Number of rows equal to number of columns, so it is called the square matrix. Now move on to the scalar matrix, and this is again important, and diagonal matrix is also important. Scalar matrix, diagonal entries are same. See, suppose 4, and here I will write down 0, here I will write down 0 and 4. So diagonal, I told you, you have to consider from left to right. This is diagonal. So diagonal entries should be same. It's called the scalar matrix. Now is the diagonal matrix. Diagonal entries are not 0. So see here, here is suppose 4. I will write down 3, 0 and 0. Here if I will write down suppose 5, 0, 0, 0. Okay. In a scalar matrix, 4, 4, diagonal entries should be same. Right, but not 1. If it is 1 here, it is the identity or unit matrix. I will write down here. So I will show you the difference, because these 3 are very important. This one. If the diagonal entries are 1, all are 0, it is the identity matrix, which we have discussed here, identity or unit matrix. But if the diagonal entries are same but not 1, 2, 3, 4, 5, whatever, both are same, or if we have 3, just like I will show you here, suppose 4, 0, 0, 0, 4, 0, 0, 0, 4. See, these diagonal entries are same but not 1. It is called the scalar matrix. And diagonal matrix, there should be some numbers. in a diagonal but not same. If it is same, it will be the scalar matrix. Diagonal entries are not zero, right? You can have 1, 2, 3. These two are different. All are zero is called the diagonal matrix. These are very important: identity matrix, scalar matrix, and diagonal matrix. And again, I'm going to explain you in identity matrix, the diagonal entries should be 1. All are 0 is called the identity matrix. While in the case of a scalar matrix, these diagonal entries should be same but not 1. If it is 1, it is called the identity matrix. 2, 3, 4, but it should be same, it is called the scalar matrix. In diagonal matrix, diagonal, there should be some entries but not 0 in the diagonal matrix. All other are 0. But in diagonal matrix, one important thing is, if only one diagonal entry is non-zero, all are 0, it is also called the diagonal matrix. If all are 0, it is called null, right? But diagonal entry, not this one, diagonal entry, there should be one number which should be not 0, is also called the diagonal matrix. So I think these concepts are clear. Now we are going to start the questions. So the question number 1 is identify unit matrix. First, again, you should know what is the meaning of unit matrix. Diagonal entries should be 1. Row matrix, which has only one row. Column matrix, which has only one column. And null matrices means you have all 0 entries. So we have to find out starting from A. So see, A, all are 0. So it means it is the null. This is null matrix. Move on to B. In B, we have one row. It is called the row matrix. C, you have one column. So it is called the column matrix. In D, see, diagonal entries are 1, all are 0. So this is called the identity matrix or unit matrix. E, only one entry and it is 0, so it is the null matrix. F, there is only one column, this is called the column matrix. Question number 2, identify the square matrices, rectangular, row, identity, and null matrices. So square, again I am going to explain. Square means number of rows is equal to number of columns. Rectangular matrix, number of rows is not equal to number of columns. Row, only one row. Column, one column. Identity, diagonal entries should be 1. Null matrix, all entries should be 0. So come to number 1. We have 1, 2 rows and 3 columns. So this is not the square matrix, because in a square, number of rows should be equal to number of columns. These are different. So this is the rectangular, right? Rectangular matrix. Here is one column matrix. This one, 2 rows, 2 column. So this is the square matrix. This one, the first one. This one, right? This one, diagonal entries are 1. So this is the unit matrix. Here 1, 2, 3. 3 rows, 2 columns. Different. So this is called the rectangular matrix. And this is one row. This is called the row matrix. Seventh is one column. So this is the column matrix. Here 1, 2, 3. 3 rows, 3 by 3 and 3 columns. So this is called the scalar matrix. In a scalar, you have number of rows is equal to number of columns. And the last one is null, because all entries are 0. Now move on to question number 3. Identify diagonal. See, diagonal, scalar, unit identity matrices. So again, scalar means number of rows is equal to, no, sorry, scalar means diagonal entries should be same. For diagonal entries should be different, right? But there should be some number, not zero and in unit. So see, starting from here, this is diagonal entries are same. So this is the scalar. But it should not be 1. If it is 1, it is called the identity matrix. So 2, 3, 4, whatever. And then this one is called the diagonal. See, in diagonal, I told you that diagonal entries should not be 0. These are not 0. All are 0. This one is unit or identity matrix. This one. See, again, this is the diagonal because I told you in diagonal, there should be at least one entry. So this is the diagonal. All are 0, that is fine, but diagonally there is 3. And this one you have to solve it. 5 minus 3, if there is some negative or positive sign, then you have to subtract or add. So this 0, 2 and 0. So what do you think? What this matrix is called? See, diagonal entries are same, scalar. This is the scalar matrix. And here in the last one, I have mentioned scalar, sorry, so this is the square. Number of rows is equal to number of columns. Okay. Now is negative of a matrix. This is the new term, very, very easy. Negative of a matrix is obtained by inverting or changing the sign of all entries. I will give you the example. Suppose we have one matrix -2, 4, suppose 5, 6, 7, and here we will write down 8, or this is suppose -7. And this is called matrix A. So you have to find out the negative of this. So you have to write down like this. Minus A. Minus A means we are going to write the negative of. So if you have some negative, you have to make it positive. This is 4, it will be -4. This is 5, it is -5. 8, it will be -8. This is -7, it will be +7. This is 6, so it will be -6. So wherever you have positive, you have to make it negative, and wherever you have negative, you have to make it positive, and vice versa. Right? Positive, you have to convert it in negative. If you have negative, you have to convert in positive. This is called the negative of a matrix. Right? So here are few questions. Find the negative of the following matrices. So I will write down here how you have to write down. You have to write down minus A. See, in this is A, but I have mentioned here minus A. It means I am going to make the negative of this matrix. Negative A. So this is this 1. So see, this is positive 1, I made it -1. This is 0, remains the same, -1 is +1. This is the negative. Here minus B, negative, because we are going to make the negative of this. So just change it. 3 will be -3. 3 will be -3. 1, -2, -1. This one. See, just change the sign. So similarly, minus C, just change -2, -6, -3, -2. So easy. Now D, negative D equal to, just change the sign. This is 3, 4, -2 and -5. Negative E means negative of E. So just change the sign. It will be -1, -2, +5 and -3. So see, it's finished. Now is the transpose of the matrices. A new term, but a very easy. Transpose of matrices. Transpose of a matrices is obtained by converting all rows into columns or all columns into rows. So I will show you here. Suppose we have a matrix 1, 2, 4 and 6. And this is, I will write down X. You have to represent the matrices with the capital letter. So here I have used X. So how we will get transpose? X, and then we have to write down T here. T means transpose. So what is the definition? That you have to convert rows into columns or column into rows. You will get the same answer. So see, I will show you here. This is 1, 2. This is row 1, 2. So make it column. It will be 1, 2. This is 4 and 6. Row. Make it column. 4 and 6. This is called the transpose. Finished. Here I will show you. Here I have made this rows into column. But same question, but I am going to make column into rows. See, same thing. This is one column. So make it row. 1, 4. This is second column. So make it row. 2, 6. So see, both are same. So transpose means you can convert rows into columns or column into rows. Now here is the question number 5 and we are going to solve. So how you have to write down A transpose equal to. So see, this is one column 0, 1 and minus 2. Just make this 2 row 0, 1 and negative 2. This is the transpose. B transpose, how you will write down the second B transpose? This is one row. Make it column. 5. There is no need to change the sign. Only you have to convert rows into columns or column into rows. This one, C. How you will write down? C transpose. See, this is one row. Make it column. 1, 2. Second row, make it column. 2, negative 1. Third row, 3 and 0. This is the transpose of C. Here is D. D transpose. So here I will show you column. This is one column. Make it row 2, 0. Or this is second column 3 and 5. So either way, you will get the same answer. If you will convert rows into columns or columns into rows. So this is E transpose. Here suppose this is one row, make it column 2, 3, second minus 4 or 5. I will show you if you want to see E transpose. This is one column, make it row 2 minus 4 and this is second column, make it row 3, 5. See, both are the same. If you will convert rows into columns or column into rows, you will get the same thing. And last is, I believe, F transpose is equal to one row, make it column, second row, make it column. This is the F transpose. So in transpose, you have to convert rows into columns and column into rows. Question number 6 is the last question and very important question. Verify that A, suppose A matrix is this, B is equal to this, then you have to prove that A transpose whole transpose is equal to this A. What is the question? A transpose, then parenthesis whole transpose is equal to A, or you can say you have to prove left hand side is equal to right hand side. And A is, keep in mind, A is this parenthesis, this bracket 1, 2, 0, 1, this matrix. So A transpose, A, first you have to find out A transpose, the inside of this parenthesis. So this is the A. So I told you this is one row, make it column 1, 2. This is second, make it 0, 1. This is A transpose. Now whole transpose, right? A transpose, whole transpose. Now you have to make the transpose of this, not the original A. See, A transpose, then whole transpose. So here is, this is one row, make it column. This is one row, make it column. And what is this? 1 2 0 1. This is C, 1 2 0 1, which is equal to A. So we have proved that A transpose whole transpose is equal to A. Or you can say left hand side is equal to right hand side. So very easy. If it is if in the question it is asking A transpose, so this is the A, make the transpose of it, then whatever the transpose, again take the transpose of this, so you will get back A. Here is the B transpose, this one we have to consider this. So here I will write down B transpose, right? First you have to take the transpose of B. So this is one row, make it column 1 1. This is another row 2 0. This is the B transpose. Now do not consider this one. Now we have to consider this B transpose, then whole transpose, transpose of this B transpose, right? So this is one row, make it column. This is one row, make it column, and see, it should be same. 1 1 2 0 1 1 2 0. So we have proved that B transpose whole transpose is equal to B, or left hand side is equal to right hand side. So in this lesson you have learned kind of matrices, negative of matrices, and the transpose of matrices. If still you have any question, you can write down in comment section, but please do not forget to subscribe to my channel Sci My Academy, and thanks for watching.